I was trying to rush it. I swear I was trying
Good afternoon, everyone. Unfortunately, other microphone is not working. That's why I'll have to use this big one today. How are you all? Good. Working hard with your assignment?
Yeah.
It's almost done? Okay. So, any last moment question you want to ask about the assignment? Anything you want to ask?
Sorry, you may want to cover this, but I just haven't written it down. Is there a particular amount of references that you were looking for?
Not really. So anything, it's your liberty on how much you should put in. But like, I would like credible academic references rather than some web addresses or some online sources. Because you don't need to put all of these, just few, maybe around 5 credible academic references. I would be happy. Probably some of you are, I got a couple of emails yesterday and this morning that some of you are struggling with cover page or what we call it, cover sheet. There is a particular cover sheet you need to fill in, and like you were just wondering that whether you can submit a separate assignment document and a separate cover page in the Turnitin. Unfortunately, you can't do that. You can't submit 2 separate documents. So what you need to do is you have to assign your cover sheet, and you need to make it a PDF, and also probably you can convert your main document into PDF and can merge them. That's a one way. Other way is, I don't know, do you have any Word version of this cover page?
Yes, there's a Word version on the uni website, there's a PDF version, and if you're using one of the student computers, Acrobat on those student computers allows you to merge.
There should not be any issue in that case. You can search in the university webpage. There is a, like as you were saying, there is a Word version, PDF version. So what you need to do is you need to attach the cover page with your main document. That's my point. Okay, that's the formal way to do that. And also, like, I'm just getting some typical question that some of you are asking me about the budget and timeline. Like, some of you are probably a bit overthinking that how do I prepare a budget? I don't have any idea about like how much usually a researcher charge for data analysis, or preparing a report or collecting data. Actually, that you don't need to go for that much thinking like how much they actually charge. What I'm simply expecting that just come up with an arbitrary or like a hypothetical budget, and also a hypothetical time period that you are supposed to take for doing the research, and then allocate them in each stage of research. So it doesn't need to be actual, or doesn't need to be how much the researcher actually wants, because you don't know that. So what I just want to see that you know that you need to put a budget, you know that you need to put a timeline in your research proposal, and also you know that this budget and timeline should be allocated to different stages of research. That's what you need to know. Now the amount and time doesn't matter. Okay. Anyway, so let's start our today's lecture. Our today's topic is basic data analysis descriptive statistics. We already had some preliminary ideas about descriptive statistics in the last class, so we will continue discussing this and also some additional points. So this is chapter 20 of your textbook. So specifically, the learning objectives we have today are, we will start discussing with descriptive statistics or descriptive analysis. That means, first of all, we will discuss what a descriptive analysis is and why that is important or why that's necessary. We will be talking about tabulation, cross-tabulation. Those are related to frequency distribution and percentage distribution that we learned in the last class. We will also be talking about basic data transformation. Actually, you know, when we collect raw data, sometimes we need to transform our raw data into a more usable form, into a more usable manner to do the statistical analysis. So we will learn some of these techniques, how we can transform data. And we will see some softwares that we usually use in conducting descriptive analysis. So first of all is descriptive analysis. As you can remember, in the last class I told you that when we collect data and we have the data in a usable manner, let's assume that you have data, you have organized data, and you have the raw data ready for statistical analysis. The first thing we do is descriptive statistics. Our first thing we do is descriptive analysis. So it's basically transforming your raw data into some statistics that will help you understanding your data. And as we have already learned that as far as the descriptive analysis is concerned, we typically do measures of central tendency. That means we typically calculate measures of central tendency, and we also calculate dispersion. Measures of dispersion, we look at the shape of the distribution. Okay? I believe you didn't forget what are the measures of central tendency. Can anyone remember measures of central tendency? Okay. What's the most common one? Mean. Arithmetic mean. Mean, median, mode. So we calculate them. Then we also look at the measures of dispersion. Measures of dispersion basically tell you how spread your data is, how variable your data is. So what are the measures of dispersion? Anyone?
Deviation.
Standard deviation.
Standard deviation.
Standard deviation. Anything else? Range is the most easiest one, but most widely used one is the standard deviation. Okay, let's give you an example, and I will ask you that what descriptive statistics or what descriptive technique we will use for this analysis. Let's say that you have a sample of 1,000 Australian consumers, and you are asking them two questions. One is, what is their favorite soft drinks? What's the favorite soft drinks? And how much price they pay for each unit of soft drinks. Okay? Look at these two questions again. What is the favorite soft drink? And how much price they pay for each unit. Okay? If these two are the questions, then can you tell me, and you collect data, can you tell me what descriptive techniques or statistics you will try to find out from these two questions, from these two variables? One is favorite soft drinks, another is the prices paid. 1,000 customers were surveyed.
Do you mean like the average price?
Average price they are willing to pay. Okay. Anything else?
Frequency of one soft drink over another.
The
frequency of one soft drink over another.
Frequency of one soft drinks over another. What do you mean by frequency? I mean,
how many times somebody picked that as their favorite?
okay. So you're talking about the first question. So, like, probably people will come up with different rounds, and if you want to find that out, which technique we actually will look at? Like frequency of one over another. So what particular technique you will look at? Histogram or a frequency distribution that we looked at in the last class. So try to understand this point. One, as he said, that he will look at a histogram or a frequency distribution to see that what's the frequency of each brand of soft drinks probably. And what she said that she will look at average prices, average price consumers are willing to pay. Now, do you find any difference between these two? Like one is looking at a histogram or a frequency distribution and other is looking at average. Why different? Why both of them are not coming up with the same one? Like either a frequency distribution or an average. Why not?
Depends on the researcher's objectives and looking at the different measures, without knowing the proper terminology, might
Measurement scale, I think you were talking about.
Maybe might highlight another perspective on the subject of the research that will be of interest to the client or might allow you to do further research. So you might identify something that needs further investigation through looking at different perspectives of the data. Not convinced.
Not fully. Anybody else? Anybody else? Like, why? Yes.
I think you need two variables, don't you?
Well, two variables, but like what I'm asking that one of you is suggesting that you should look at mean, but other is just a frequency distribution. What's the difference between these two, and why one is choosing mean for one and another is choosing like a histogram or a frequency distribution? In it, like, is the particular characteristics of the variable that has like prompted them to use this one, or what? Look at the two questions. Two questions, responses will be different types. Why? Because the first question was, what's your favorite soft drink? What type of answer you are expecting? A brand name. So probably you will have a couple of responses. For example, say Coke, Pepsi, or something else. So you will have a couple of responses. The other question is, what's the average price they are willing to pay? So that will actually have probably a big range. Yes or no? And in that case, you will get some numeric numbers. Yes or no? So, do you think that measurement scale of these two variables will be different? Can you remember the measurement scale we learned earlier? There are 4 measurement scale. Can you tell me what are these 4? No one? Like as I discussed that, you need to know what measurement level your data is, because that will dictate what statistical technique or what descriptive statistics will you use. Can you remember this? At least 1 or 2 out of 4. You? No? Anyone? No? Okay. Can you remember we learned about nominal, ordinal, interval, and ratio? Can you remember them? These are actually like the measurement scale of the variable. As we said that we provide some numeric numbers as identification, as ranking, the ordinal one, then ranking, at the same time it captures differences. Can you remember them? Okay. If you can remember now, can you tell me, like, if the first variable that you have, the favorites of drinks, what measurement scale it's having? Like, if you get some brand names as favorite drinks, so what measurement scale it has? Nominal, ordinal, interval, or ratio? What do you think? It's nominal because, like, if you have some brand names, you will basically putting some numeric numbers for identification. For example, probably 1 for Coke, 2 for Pepsi, and 3, 4, 5 for some others. So that's actually a nominal variable. Okay. What about the price? Like, you are asking what price they pay for each unit of their favorite drinks. So what measurement scale this variable is? That's ratio. That's ratio scale. Yes or no? Okay. Now, if you understand these two, that nominal, if you understand these two, that nominal, in the case of nominal variable, as one of you picked up the frequency distribution or histogram, and for a ratio variable, one picked up average, look at this information now. What descriptive statistics or what descriptive technique you will be using, that also depends on what is the measurement scale or what's the measurement level of your variable. Okay? So, probably you can remember I told you earlier that nominal and ordinal are generally called the lower scale variables, or they call non-metric variables. And interval and ratio scale, they are called metric variables, or they are called higher scale variables. Okay? So if you have a nominal and ordinal variable, then the statistic or the technique that you should be using is frequency table or mode. Okay? That means if your variable is a nominal one, then frequency distribution is a good way of presenting your descriptive analysis. However, if your variable is in interval or ratio scale, for example, the one we had, price they are willing to pay, if it is interval or ratio scale, then descriptive techniques that you will be using is mean and standard deviation. Okay? So that's why I was asking that if you have these two questions, what descriptive technique you will be using, because descriptive techniques do not necessarily same for all the variables. Now, these two examples that we have, at the top you can see there is a histogram. Okay? In this case, the question asked to the respondents was from where they buy beer. I mean, it's a drinks, and what's the source of these drinks, from where they buy it. So there were 4 alternative answers: drugstores, convenience stores, grocery store, and specialty store. So these are the 4 sources they buy beer from. And you can see there's a histogram below as well. And in this case, the question was similar to the one that I was previously asking, that what price they pay for each unit. Okay? And in this case, you can see a histogram is there, and the mean price is 11.6667, standard deviation is 4.54. Okay? So for this, when the first question was from where they buy beer, there's a histogram is the best way to present this result. And in the second, when they were asked that what's the price they pay, in that case, it's histogram. At the same time, the other descriptive techniques, for example, mean and standard deviation, are used. So probably you understand that when you have a nominal variable, you are using histogram. I mean, nominal and ordinal variable, you are using histogram. And when you have an ordinal, when you have an interval or ratio variable, you are using histogram as well as mean and standard deviation. So these examples actually imply that descriptive techniques, those are suitable for lower scale variable. Descriptive techniques, those are suitable for lower scale variable. Those are also suitable for higher scale variable. But descriptive techniques, those are suitable for higher scale variable, may not be suitable for lower scale variable. Is this statement clear or not? Again, I said, descriptive techniques, those are suitable for lower scale variable, is also suitable for higher scale variable. But those are suitable for higher scale variable are not suitable for lower scale variable. Okay? So, for example, histogram, it's suitable for lower scale as well as higher scale. Yes or no? Like you can see the histogram for the first question and also for the second question. However, if you talk about mean and standard deviation, Then we do not calculate mean and standard deviation for the first question. That means this mean and standard deviation is suitable for higher scale, like interval and ratio, but it's not suitable for lower scale. Is this point clear? I don't know why it keeps happening. Okay, so can anyone tell me why the descriptive techniques that we use for higher scale variable, for example, interval and ratio, why they are not suitable for lower scale variables? For example, mean and standard deviation, we have calculated them for interval and ratio scales, but we didn't do them for nominal and ordinal. That means these are only suitable for higher scales, not for lower scales. Can anyone tell me why? Why they are not suitable?
Those aren't numbers.
Those are?
Those aren't numbers.
Okay.
So for example, if you have two brand names, you
Mhm.
can just merge it.
Mhm.
So you have no mean to calculate.
Well, but yeah, that's a good answer. Actually, if you have a nominal or ordinal variable, you put numeric numbers just for identification purpose, or say a sort of ranking purpose. For example, you have like drugstore, convenience store, a specialty store, so you will put some numeric numbers like 1, 2, 3, 4. Now, if you calculate mean or standard deviation, that won't mean anything because that will not have any significance. Yes or no? Like if you take mean or standard deviation, that will not have any significance. Like if you take, let's say you have a variable gender, so male and female. Now you put 1 for male and 2 for female, okay? And since you will have some 1s and some 2s, if you calculate mean, probably it will be like 1.5. So what does it indicate? If you say that mean of gender is 1.5, that doesn't mean anything. Okay, that's why the statistical techniques or descriptive techniques, those are suitable for higher scale and not suitable for lower scale. But you can see this histogram that we have done for nominal and ordinal. If we do the same for higher scale, we still get some information. So by this time, we already talked about histogram. If I just provide you a formal definition of histogram, you can remember we learned about frequency table in the last class. Can you remember frequency table? And in frequency table, we have seen that we actually show the frequencies. Frequency means number of times a particular observation appears. That was a frequency table. And histogram is basically a graphical representation of the frequency table. That means if you have a frequency table, if you show it graphically, that is histogram. So in histogram, you will have some bars. Each bar will show you the frequency. For example, that we have in this case, like in this case, you can see the drugstore and convenience store, grocery store, and specialty store. The height of each of these bar indicates that how many people buy the drinks from drugstore. For example, you can see drugstore is close to 10, convenience store is close to 45, grocery store is close to 35. So height of each bar is indicating that what's the number of respondents buy their drinks from this particular type of a store. So that is histogram. Now, tabulation. Tabulation is actually a frequency distribution that we discussed in the last class. So tabulation is a way of arranging your data, is a way of representing your arranged data. That is tabulation. So when we say that we tabulate, what we actually do. For example, when we get the final result of a course, we tabulate them that how many students got a particular grade. For example, we have say 50 students, we get grade for each of the student, then we tabulate them, how many got D, how many got HD, how many got C, how many got F. So that's actually tabulation. That means you have 50 observations and you have a criteria that grade, and you tabulate them means you make an orderly arrangement of the data. So that is tabulation. If you look at this example, we already have seen a histogram for this tabulation. Now it's just in tabular form. As I already have said, that the question that were asked is from where the respondents buy beers. So you can see that drugstore frequency is 50, convenience store is 225, grocery store is 175, specialty 35, and other 15. So it's actually a representation of your orderly representation of your data. So you tabulate the data and show the number of respondents provided a particular response. Now, actually, why I discussed cross tabulation, as I already discussed frequency table in the last class. So tabulation is very similar to frequency distribution. Now, if we talk about cross tabulation, actually, cross tabulation, you can say, if tabulation is a frequency table, then cross tabulation is a combined frequency table. Okay? So what does it mean? It means that when you do tabulation, that means when you tabulate, basically we report one variable or we summarize one variable. And when we say cross tabulation, that's actually the representation of more than one variable. Okay, so that's why we say it's a combined frequency table. Now, if you have two variables, for example, both of the variables are less than interval scale. Less than interval scale means either nominal or ordinal. If two variables are less than interval variable, then cross tabulation is the best way to represent the statistics, represent the descriptive statistics. Okay? Again, I say, if you have two variables and they are less than interval means nominal or ordinal, then cross tabulation will be the best way to represent the descriptive analysis. So in cross tabulation, we will have one variable in the row, one variable in the column, and we will show the relationship between these two variables. Okay? Look at this example. So in this example, first of all, look at the question at the top, cross tabulation question. Have you followed the news stories about AIG bonuses? Okay? Have you followed the news stories about AIG bonuses? So as I already have said that in cross tabulation, it will show two variables, one in the row, another in the column. So closely followed news stories about AIG bonuses. So these are the answers. Very closely, somewhat closely, not very closely, not at all, and not sure. Okay? And 55%, these are the number of adults, 55%, 33%, 8%, 2%, and 2%. So what does it mean? It means that, look, if you have a table up to this, that means it's 55%. If you have a table up to this, then it's a tabulation that we discussed earlier. Now, if you extend this tabulation to some other variables, then it becomes a cross tabulation. You understand my point? That means if your table only shows that 55% of the adults very closely followed the news, 33% of them somewhat closely followed the news, 8% not very closely. If you have only this information in your table, then it will be a tabulation. Now, when you combine some other variables here, for example, gender and age, then it becomes a cross tabulation. Okay? For example, you can see that men and women, so 60% and 51%, it means that among the respondents, among the male respondents, 60% of them closely followed the news, and among the female respondents, 51% closely followed the news. 30% of men somewhat closely followed the news, and 35% of women closely followed the news. Okay? So you understand that when we extend our tabulation to a cross tabulation, we get some additional information. Okay? So, can anyone tell me, when we go from tabulation to cross-tabulation, I mean, when we show only one variable, that what's the percentage of the adult respondents, how closely they have followed the news, and when we extend it to cross-tabulation and include two other variables, gender and age, what additional information we get? Can anyone tell me? What additional information do we get from the cross-tabulation compared to the tabulation?
Isn't that what you just said, though? The extra information is gender breakup and age breakup.
Okay, gender breakup and age breakups. Do you find any pattern, like across the genders and across the age?
Quite similar between women, percentage-wise. Is that what you're asking?
Characteristics of adults.
Hmm?
Characteristics of adults.
Characteristics of adults.
They're either male, female.
Hmm.
They're 18 through 64, 65.
Hmm.
Age.
Okay.
Has to be directly associated with the adult.
Yeah. Look, when we have only like information, those are adults, what we get is what's the percentage of adults are like either very closely following or somewhat closely following. Now, if you go to age, all of them are adults, okay? So from 18 to 65. Now look, if we take these very closely answers, then 41, 49, 52, 67, 68. So, in general, what we said earlier, 55% of the adults very closely followed the news. Now, if we look at these percentages, 41, 49, 52, 67, and 68, do we find any pattern?
The elderly people, much of the people. It
Yeah.
increases with age, so the younger they are, the less they're watching.
Yes. So definitely we find a very clear pattern that higher the age, more closely they followed the news. Yes or no? And younger the age, less closely they followed the news. Okay? Particularly the very closely one. And if you also take this gender breakup, you can see that, as I already had said, that 55% of the overall respondents very closely followed the news. But if you break them up in men and women, then 60% of male respondents very closely followed the news. However, the women percentage was only 51%. So we can say that in general, the male respondents were more closely followed the news compared to female respondents. And in terms of age, when very closely is the response, the higher the age, higher the proportion of people very closely followed the news. So that's the purpose of cross-tabulation. That means a tabulation gives you a very general information, but if you extend your tabulation to cross-tabulation, you get some additional information, you get some additional insights.
I'd say it's like drilling down into the data.
You are right, you are right. So you are digging deeper, you are digging deeper, you are getting some more insights. And a very similar one is the question below. Now, tabulation, cross-tabulation. After that, we also go for contingency table. Okay, sometimes we prepare contingency table. Now, contingency table, when we prepare a contingency table, one additional feature of contingency table compared to cross-tabulation is it actually represents some combined responses. Okay, some combined responses. I will show you an example. So in cross-tabulation, as I said, that you will have one variable in the row and one variable in the column. You may have more, but at least one variable in the row and one variable in the column. That's cross-tabulation. Contingency table is also a cross-tabulation. Okay, also a cross-tabulation, but you will combine some responses as you get some more information. And in the contingency table, you will have a row and column that shows you the basis of these combined responses that we call marginal. That means the rows and columns of the contingency table are called marginals. And that actually shows you what's the basis of the combination of the responses. So look at this example. So first of all, what you have is a cross-tabulation question question is, do you shop at Target? Okay. Do you shop at Target? And there are two types of responses, men and women, and two responses, yes or no. Okay. So there are total 225 men, 150 of them said yes, and 75 of them said no. Okay. And also there are 225 women, 180 of them said yes, and 45 of them said no. Okay. So total 450 respondents, 300 of them said yes, and 120 of them said no. Okay. Now, if you go back, in this case, you can see we simply provided some percentages, but in this case, what we are doing, look at in this middle. So what we are taking is, we are taking this beige, that means this extreme right column, we are taking this as 100%, and then we are expressing these answers in the form of percentage. Like 66.7% is saying yes, 66.7% of men is saying yes, and 33.3% of men saying no, and 80% of women saying yes, and 20% of women saying no. Now, if we change this base, and instead of like this men and women, if we change the base and we take them as yes or no, then we provide some combined result. Okay. So, for example, for men, 45.5% of saying yes, and sorry, out of 330, that's like yes, out of 330, 45.5% are coming from men, and 54.5% are coming from women. So in this case, what we are doing is, actually, we are combining the responses. Okay, we are combining the responses, that from the yes, how many are coming from male and how many are coming from female. So these are like tabulation, cross tabulation. These are different ways of presenting our data. The statistical base, I already have discussed that you have the column total and you have the row total, and you are expressing each frequency in the table as a percentage of your column total or row total. Okay. Elaboration analysis and moderator variable, sometimes we go for them when we want to extend our cross tabulation analysis. So elaboration analysis is just the one that we have seen, that first of all you have, for example, a tabulation, then you break it down to gender, then you break it down to age, probably you include some more variables, maybe income level, maybe geographic location. So you just elaborate your analysis. You add some additional variables to get some more information. And also, we introduce some moderator variables sometimes. Moderator variable means like your primary interest is two variables. Your primary interest is to find out the relationship between two variables, but sometimes it's possible that you introduce a third variable and check that whether the relationship still exists or not. Okay, you understand what I'm trying to say? Let's say you have two variables, x and y, and your interest is what's the relationship between x and y. You find that, okay, there is a positive relationship, but there is a negative relationship. Now, sometimes you introduce a third variable, that we call moderator variable. You introduce a third variable and check that whether the relationship is still exists or not, whether the result that you get is still exists or not. Okay, so that's called moderator variable. Look at this example. So we still have the same question. Do you shop at Target? If I just go back, if you can remember that when we had the question, do you shop at Target, 150 of men said yes and 75 of them said no. So 66.7% of men said yes and 33% of them said no. 80% of women said yes and 20% of women said no. Now, if you look at this and if you break down that information on the basis of their marital status, then look what information we get. When our respondents are single, then 55% of men said yes and 45% of them said no. And when they are single, 80% of women said yes and 20% of them said no. But when they get married, and as far as men is concerned, 86% of them said yes and 14% of them said no. And in terms of women, 80% of them said yes and 20% of them said no. Now, this is actually an elaboration analysis, you can say, that you are extending. At the same time, now you are introducing another new variable. What's that? The marital status. Now, do you find any additional information when we introduce this marital status? I just show you once again that the initial information that we were given is 66.7% of men said yes and 33% said no. 80% of women said yes, 20% of them said no. That's the overall result. Now, when we are dividing them based on single and married, so 55% of men said yes, 45 no, when they are single. When they are married, look at the percentages. So what information you get? Any difference between the overall result and this result?
Males have increased.
Okay. If you can remember, in our overall result, 60%, around 60% of males said yes. And when we are dividing them, when they are single, 55%. That means overall result was 60%, and for single, it's 55%. That means overall result is pretty much close to the result that we obtain when they are single. However, when they get married, you can see that the percentage increases substantially from 55% to 86%. So you understand that when we are introducing this additional variable marital status, we get one additional information that when the male respondents, when they get married, that means these married male respondents have a higher tendency or higher propensity to shop at Target. Okay, so this, you can see that this information you didn't have when you had the overall result. So in this way, when we introduce a different variables or we go for an elaboration analysis, this type of cross tabulation may provide us some additional information. Now, you can have a typical question even when you will be doing your assignment 2, like you will actually be doing some data analysis, you will actually have some data. So you might have a question that how many cross tabulation? Because you understand that the examples that we have seen, there was a simple question. What? Do you shop at Target? A simple question. You can remember this simple question could be extended, like do you shop at Target? Then you broke it down to on the basis of gender, then on the basis of marital status. So you can see that each question, each responses, each type of respondents can result in one cross tabulation. Now, it's possible that in your questionnaire there are, let's say, 20 questions. And in these 20 questions, there may be some interrelationship. Like question 1 is related to question 2. For example, in this case, we had marital status, gender, age group, so different questions are related to other questions. And if you keep doing this type of permutation combination and keep creating this cross tabulation, probably you will end up having numerous cross tabulations. Yes or no? So the question is, how many cross tabulation? Any answer?
As many as you need to get your result. You desired result.
What do you mean by desired result?
Well, obviously, if you're doing this, you're trying to figure out particular variables until you actually reach that target of achieving that variable, then you would probably cross-reference as many as you could.
Well, you know that unless you go for these different cross tabulation, probably even you don't know that what result you can obtain. For example, in this case, we have seen that when we are introducing marital status, in this question, we are finding an information that, the frequency of their visit to shop depends on whether they are married or married or single. So unless you prepare this cross-tabulation, you will probably do not know what results you are expecting or what results you can obtain.
So you're saying one for all variables?
One for all variables. What do we mean? Like you will have one cross-tabulation that will include all the variables?
Well, Tanya suggested as many as required. You're suggesting that as many as required might not be sufficient. So are you saying that a cross-tab will need to be done for all variables?
No. My point is, what do you mean by as many as required? That's my point. What do you mean by required? Because, like, even you don't know what's required unless you prepare all the possible combination of cross-tabulations.
But surely before you start this, you have a goal in mind. So for target consumers, for example, yes, it's great you've got your percentage, and then you've broken it down to gender and married or single, whatever it might be. But then you could be branching off to, are you buying for your children? Because when you're married, you might be buying for them.
Right.
What's the relevance of that information? Like, why would you be dishing in so much info if it's irrelevant to who you're actually doing this for?
Okay.
Or it's for yourself.
Okay.
Or maybe if the trend remains the same.
I think that's where I'm getting.
That's a good point. That's a good point.
3 times, then cut it off.
Okay. Look, what we have seen here that we prepared a cross-tabulation based on gender, and we found an interesting pattern that, okay, when people are getting married, their frequency of visit increases. Now, what if we didn't get it, and the result after married and the overall result are same? Like, what if this cross-tabulation doesn't give any result that's significantly different from the overall result that we had?
Then we can say there's no significant difference between males and females.
Okay. Okay.
Maybe you're just testing your theory. Testing it, and if it comes out consistent, then it's
Okay.
You're not going to say, does she have a dog? Does he have a dog? You're not going to stop going. Kids.
Okay. What I'm trying to say is, fortunately, nowadays we have some softwares. Okay. What the softwares will do is, the softwares will create all possible cross-tabulations, like if you have 20 questions, different answers, like different possible responses, it will prepare all sorts of cross-tabulations and will present you the result where the cross-tabulation results are somewhat different from the overall result. Okay, so that's the point actually I wanted to find out, that first of all, cross-tabulation, when you are presenting it in your research report, like you understand that if you present numerous tables, then you will lose the attraction of your readers. Okay, so you want to present only those tables that have important information. Okay, so that software can help you in this way, that it will come up with only those cross-tabulations that have information different from the full sample result or different from the overall result. Now, once again, it's a machine, so it doesn't know what is your primary research objective. That's why sometimes it's possible that you may come up with some cross-tabulation, probably those are not very important for your main research objective. In that case, you can just eliminate them manually. Okay. So the point I want to say that, to summarize, or the bottom line is, we need to present only those cross-tabulation, those have important information, and those are different from the overall result. Okay? So if our cross-tabulation result is not different from the overall result, then there is no benefit of presenting those cross-tabulation. Okay? This is the first criteria we should look at. And the second criteria we should look at is whether the cross-tabulation is relevant to at least one of our research objectives. That means whether the cross-tabulation is contributing to any of our research objectives. So based on these two criteria, we need to find out that how many cross-tabulation will be best to present in our research report. One extension of cross-tabulation is quadrant analysis. Okay, so it's actually an extension. So in this case, I think you didn't forget, as I said, that cross-tabulation is particularly suitable when you have two variables or you have two questions. Those generate response that are less than interval scale. Okay, that means you have two less than interval scale variable, you present them in the cross tabulation. That's the best way to do. Now, quadrant analysis, as I am saying, that an extended version of cross tabulation. In quadrant analysis, you will have two rating type of question. That means if you have two rating type of question, you are asking your respondents to rate something. So if you have two rating type of question, then quadrant analysis is suitable. Okay? In quadrant analysis, you will have two rating question. You will get the responses from your respondents about the rating, and the summary of the result will be presented in a quadrant, okay, in a two-dimensional quadrant. Look at this example. In this case, you actually surveyed some respondents who stayed in a hotel, okay? A survey of people who stayed in a hotel. You asked them to rate these characteristics. Look at these characteristics that we usually look for in a hotel. So prompt service, room prices, quietness, room cleanliness, breakfast availability, attractive interior, entertainment, and 24-hour room service. These are some characteristics, okay? You ask your respondent that rate them, first of all, on the basis of their performance, okay? On the basis of their performance. That means, were you happy with, say, 24-hour room service? Were you happy with the entertainment? Were you happy about the breakfast availability? So rate them, okay? Which one is most satisfactory for you? This is one. Rate them on the basis of their performance. And the second question was, rate the same characteristics on the basis of their importance. Okay? One is on the basis of importance, another is on the basis of performance. So two rating question, you got the responses, and the responses are summarized in this quadrant. Okay? So you can see at the top you have high importance, then at the bottom you have low importance. In the left you have low performance, and right you have high performance. So each quadrant, actually, you can see we have 4 quadrants. So each quadrant basically is a combination of importance and performance. Yes or no? For example, this quadrant is the combination of high importance and high performance. Okay? And look at these characteristics, room cleanliness. So what does it mean? It means that our respondents rated this room cleanliness as a high importance variable. Room cleanliness as a high importance variable, and it's also, like, its performance is also high. You understand my point? Then, look at this quadrant. This is a combination of low importance and high performance. What does it mean? This entertainment and 24-hour room service, these two are low importance variable. Entertainment and 24-hour room service, those are low importance variable, but their performance is high. Okay? Then, this quadrant, that means the left below quadrant, you have breakfast availability and attractive interior. So it's the combination of low performance and low importance. That means attractive interior and breakfast availability, they are low importance variable, and their performances are also low. And look at the last quadrant. This is the combination of low performance and high importance. So prompt service, room prices, and quietness. These three are high importance variable, but their performances are low. Okay? So what do you find out from this analysis? Like if this is the quadrant analysis presented to you, what information you get?
We need to improve
We need to improve.
yeah,
Which variables?
all three of those.
Hmm?
All three of those.
All three of those. I mean, prompt service, room prices, and quietness. Well, you understand that that's actually the problem quadrant. Am I right? That's actually the problem quadrant. Why problem quadrant? Look, this is a combination of high importance and low performance. That means a particular characteristics will be here if its importance is high, but it performed poorly. Ideally, we should not have anything here. Yes or no? But you can see that we have prompt service, room prices, and quietness, these three variables. That means the respondents think that they are very important, but they are not happy with the performance. Okay? That's why you can see these arrows. So arrows actually indicating that these three should go here. Is it okay? So, and look at this one. This is high performance and low importance quadrant. This entertainment and 24-hour service. They are low importance variable, but their performance is very high. Okay? Any issue with this?
Waste of money.
Waste of money. Okay. Actually, you understand that your customers do not consider them very important, but probably you are investing on those. So it's possible that you may reduce your investment in these variables like entertainment and 24-hour service, and probably you should concentrate more on these variables like prompt service, room prices, and quietness to improve your performance. So this is a quadrant analysis. And once again, I say, when you do go for quadrant analysis, if you have two rating type of variable. So far we talked about presenting data in different ways. Now, some basic techniques about data transformation. As I said that sometimes it's possible that we have data, we have raw data, but we need to transform our raw data into a form that is more usable, that is more useful, or into a form that is more suitable for statistical analysis. Okay? So I start with this example. Look, we have a question that I am satisfied with my college experience at this university. Or if I simply say that I am satisfied with my experiences at this university. It's a 5 answers: strongly disagree, disagree, neutral, agree, and strongly agree. Okay? So look at the results. 110 said they strongly disagree, 30 disagree, 15 neutral, 35 agree, and 210 strongly agree. Okay? So do you find any particular characteristics of the answer? We get two extreme answers. You can see that 110 are strongly disagree and 210 is strongly agree. Okay? This type of distribution is called bimodal distribution. Okay? Bimodal distribution. You can remember we learned about mode in the last class. So mode is the observation that comes most often. Okay? In this case, you can see that strongly disagree and strongly agree, these two answers are coming more frequently. Yes or no? So this type of distribution is called bimodal. That means you have two modes, two observation that's coming very frequently. Now, in this type of case, what you can do is, sometimes it's possible that we collapse these responses. For example, it's a 5-scale response. We collapse them probably 2 scales and simply making them yes or no to make it easier for data analysis. For example, in this case, you can see if you just delete this 15 responses, okay, 15 responses, if you just delete them, add this disagree with strongly agree. and agree with strongly agree. Okay? So if you delete this neutral, disagree is added with strongly agree, and agree is added with strongly agree, your 5 scale answers could be reduced down to 2 scale. That means it simply can be reduced down to a nominal answer, that is yes or no. Okay. So if we do that, what problem? Like, what's the limitation of doing this type of transformation? Yes.
I think what you've done is something else at play there. So there's another variable that needs to be considered. And what, by you
For
actually,
example?
something's influencing those decisions, but it's not happening to all people. So,
Okay.
a bad experience with that.
Okay. Anybody else? I'm just asking that if we do this type of data transformation, that means you have like 5 scale answers or 7 scale answers. Since you have 2 extreme answers, so you are just reducing down the 5 scale answers to 2 scale answers. What's the problem? First of all, you lose some information.
Yeah, I was about to say you missed the nuances.
That's the most general point, that you lose some answers. For example, you are deleting neutral, so you are losing some of them. You are adding disagree with strongly disagree. Okay, so you are losing the extent of their agreement and disagreement, because when I say that I agree, sometimes the extent of this agreement can vary. So we also lose that information.
You're smoothing it.
Smoothing it. Okay. We are losing this information. We understand, but sometimes we do that. Why? As I already have said, probably to make our analysis easier. And to make our statistical analysis more easy and friendly. Okay. Now, this is the case that I was talking about, the bimodal distribution. Look, you have generally what we have is generally we have one mode, but you can see we have two large bar here in the left and in the right. So it's indicating that it's a bimodal type of distribution. Okay. So if you have this bimodal type of distribution, then one way we do this data transformation is median split. That's one technique we go for sometimes, that we call median split. So median split means if you have a particular number of responses, so you just divide the data from the median. That means you calculate or you find out what is your median, and you divide your data from the median. And what you do is all the responses below the median constitute one category, and all the responses above the median constitute another category. So this is one technique actually of this data transformation. Okay. But as I already have said, that this inappropriate type of data transformation may result in losing important information. Now look at this example. So first of all, the question is in the right box. Frequency distribution. I do most of my shopping at convenience store. Okay, that's a statement. I do most of my shopping at convenience store. Now, these are the responses you get. Strongly disagree 10, disagree 40, slightly disagree 125, slightly agree 125, agree 40, and strongly agree 10. Okay, so you have 6 responses, and these are the number of responses you get. And if you put like some numeric coding to identify each of these responses, so you put 1, 2, 3, 4, 5, and 6. Okay, so you put this numeric coding. And median is 3.5. Okay, as I said, the median split means you cut your data in the median, and all the responses below the median constitute one category, and all the responses above the median constitute another category. So 1, 2, 3, these are the 3 responses: strongly disagree, disagree, and slightly disagree. And 4, 5, 6, these are the other type of responses: slightly agree, agree, and strongly agree. Okay. So what do you suggest? Like, how can you transform this data? Combine the 3 at the top in one and combine the 3 at the bottom in one. So you want to add strongly disagree, disagree, and slightly disagree in one category. Okay. So what name will you give that response? Disagree. Okay. Then you will add up slightly agree, agree, and strongly agree in one category. Right. Okay. So this is actually what median split I was talking about. That means you are just dividing the data. Since your responses are from 1 to 6 and your median is 3.5, so you are dividing the data in 3.5, and responses below the median constitute one category like disagree, and responses above the median constitute another category like agree. Now, do any one of you have any other suggestion rather than the one that I have just said? Or do you think there could be any problem of this type of median split here? Like if you add up the top 3 in one category and add up the bottom 3 in another category, this is a median half split. So is that the best way to do, or do you have any other suggestion? Or do you find any problem with this type of median split here?
The numbers are the same for the counts.
Numbers are?
The numbers are the same for the counts, like it's 10, 10, 10, 40, 125.
Mm-hmm.
Then you've got that in the reverse strongly agree version. The only problem I'd have with this is just slightly disagree and slightly agree with the end. Like I would think that the questions probably would have had to have been. Yeah. Like you're kind of sitting on the fence. Like it's, I think, you know, in normal surveys it says either disagree or don't agree or whatever, or like it's a neutral kind of comment. So I think those two kind of sit on that for me as well.
Yeah. And that's the reason it was created in this way. Yes, what do you want to say?
Well, no matter what you do to it, you're going to get a 50-50. So if you couple the top 2 middle 2 and bottom 2, you get 50-50. The top 3 bottom 3 get 50-50. So the answer.
So what do you suggest? What do you suggest? You want to go for like top 3, bottom 3, or you want to go for top 2, middle 2, bottom 2?
It doesn't help because you're going to 50-50. But yeah, well, cross out the middle 2, go with the top 2, bottom 2.
Okay. Look, if you go for the general median split that I said, that if you add the top 3 and if you add the bottom 3, probably you are losing too much. Okay, why too much? Look, what you are doing is, let's say you are adding these 3. Slightly agree, agree, and strongly agree. Slightly agree, agree, and strongly agree. It's one category. And you are adding slightly disagree, disagree, and strongly disagree in another category. Okay. Now, as you were saying, what do you mean by slightly agree and slightly disagree? Those are very close answers, isn't it? For example, when I say slightly agree, that means I slightly disagree as well. Or if I say I'm slightly disagree, actually I'm slightly agree as well. So it's basically that these two answers are very close to one another. But if we go for median split, this slightly disagree is going in a different category and slightly agree is coming in a different category. So very close to answers are getting into different category. Yes or no? So that's why this normal median split will not be very good in this case. So probably one way could be like you go for adding strongly disagree and disagree, and you simply say that that's disagree, and slightly disagree and slightly agree, you just combine them and probably name it as neutral, and add agree and strongly agree, and you term them as just agree. Okay, that could be one compromise, because if you go for this median split, that probably is not a good strategy here. So the point I'm trying to say that although median split is a general technique that we go for this type of data transformation, but that works if you have the situation that we have seen in the last slide, if you have bimodal type of distribution. Okay? But in this case, you will lose information. It will be inappropriate to go for this median speed. So that's one technique of data transformation. Another one is the index numbers. Index numbers, that means calculating or creating index number is another form of data transformation. Have you ever seen an index number? Or are you familiar with any particular index? Anyone? Like, do you follow any particular index, or are you familiar with any index number? Okay, S&P 500, that's an index of share price. Okay, good. Anybody else?
Consumer price index.
Consumer price index, very good. Anything else? Okay, so most of us are familiar with this index number. So while we create this index number, what we actually do is we transform our data, or we transform our each observation in a new number in relation to a base number. Okay? That means if you have, let's say you have 10 observations, you will transform each of these observations to a different number. You will transform each of these observations to a new number. In relation to what? In relation to a base number. Okay? And we generally do it just to facilitate our comparison. That means we go for index number so that it becomes easier for us to compare observation to observation. Okay? We have an example here. So first of all, this example is a base number, the US household average. It's actually an example of weekly television viewing. Okay? That means how many hours the US people watch television. So the overall US average, that means for the overall country, the US average is 52 hours, 36 minutes. That means the overall US average. So US people on an average watch television 52 hours, 36 minutes per week. Okay? Now you have some observations. Observations are 1% house, 2 persons, 3+ persons, and then US average. So what we'll be doing now is we will be creating some index number. So as I have said that in index number, we transform each observation to a different number in relation to one base number. So in this case, our base number is the US average. That is 52 hours, 36 minutes. Okay? So that's our base number. And then what are the individual observation? Our individual observation is, for example, 1-person household, they watch on an average is 41 hours, 1 minute. 2-person household, on an average, they watch television of 47 hours, 58 minutes. 3+ persons house, they watch television of 60 hours, 49 minutes on an average. Okay? So look how we are transforming each of these numbers. We are dividing each of these number with the base number. That's 52 hours 36. We are dividing each number with the base number, okay? With the base number, and we are multiplying them by 100. Each observation is divided by the base number and multiplied by 100. So we get some new numbers. You can see 1-person household's average was 41.1. Now we get a different number, that is 78.3. Then for 2-person household, it's 90.87. For 3-person households, it's 115.53. And the US average that's 52.36. That's 100. That's our base number. Okay. Now, do you find any benefit? Like previously our number was 41.1, 47, 58, 60, 49. Now our numbers, and 52, 36, now our numbers are 78, 90, 115, and 100. Do you find any advantage of this type of transformation? If so, what? What advantage you get by this transformation? Anyone? Want to say anything? No?
You can easily see whether it's above or below average.
Okay, so you can easily compare each number with the base, isn't it? Like now our base has been transformed to 100, and each number, for example 78, 90 and 115, each number can be easily compared with the base number. For example, if you say like 3% households is 115.53 and US average is 100. Okay, so what can we say is 3+ persons household watch television that is 15% higher than the US average. Can you say this or not? Look what I say. 3+ persons households, now number is 115.53, okay? And our base number is 100. So what I'm saying is the 3+ persons household watch television how many hours? 15% higher than the base number. Okay? 2+ person households watch television that is 10% lower than the US average. Okay? How we are getting this 10%, 15%? We are just comparing this each number with the base number. Okay? So it makes our comparison easier. So if you have a base number and all the observations has been transformed in relation to this base number, it becomes easier for you to compare.
So it's like a data point.
Yes, yes. For example, when we do we say that GDP growth rate, okay? We typically say, okay, this year's GDP growth rate is say 5%. Okay, so in this case, actually, we compare it with a certain benchmark. This year's GDP compared with a certain benchmark GDP, and we say that it is at 5% or 6%, the way we are saying here. Like 100 and 115, we are saying that 3+ households watching television 15% higher. So GDP growth rate, or when we say inflation, 5%. So this is the index number that creates this comparison easier. We are comparing each observation with the base number, and it makes us easier to understand. So this is another way of transforming data. The third one, we are still discussing data transformation. The third one is rank order. Okay. Sometimes we use this rank order concept to transform our data. In this rank order, what we actually do is we have some frequencies of particular question, frequencies of particular responses. And we also have some rank orders. So what we do is we multiply the frequencies with the rank orders to get a particular result, or to get a particular new set of data. Okay? So look at this example. So we will understand how this rank order actually works. So the example is about a corporate decision where the corporation has 10 executives. You can see executive 1, 2, 3, 4, up to 10. The corporation has 10 executives, okay? And they have their annual general meeting ahead of them. So the corporate executives were asked that what venue they will like for their general meeting, okay? And they had 4 alternatives: Hawaii, Paris, Greece, and Hong Kong. So each of these executives, 1 to 10, each of these executives were asked to rank these 4 destinations, okay, for their meeting place: Hawaii, Paris, Greece, and Hong Kong. Now you can see that executive 1 ranked Hawaii first, Paris 2, and then Paris 2nd, Hong Kong 3rd, and Greece 4. Okay, that's executive 1. For example, executive 2 ranked Hawaii first, Hong Kong 2nd, Paris 3rd, and Greece 4. In this way, each executive ranked these 4 destinations, 1, 2, 3, 4, for their meeting place next. And then at the bottom, you can see that these preferences, this ranking have been summarized. Okay, how they have been summarized. So Hawaii, there are 10 executives, 10 respondents. So Hawaii got 3 first, 5 second, 1/3, and 1/4. You understand what does it mean? It means that 3 of the executives ranked Hawaii first, 5 of the executives ranked Hawaii second, and 1 each of them ranked Hawaii 3rd and 4th. Is it okay? Paris, 3 first. It means that 3 of the executives ranked Paris first, 1 of them ranked Paris second, 3 of them ranked 3rd, and 3 of them ranked 4th. Greece, 2 of them ranked first, 2 of them ranked it second, 4 of them ranked it 3rd, and 2 of them ranked it 4th. The same as Hong Kong. 2 each of them ranked Hong Kong first, second, and 3rd, and 4 of them ranked its 4th. Okay, so that's a summary. Now, how the rank order actually works. Look at this calculation. Okay? Now, what we have done is we are simply doing some numeric calculation. In this case, if you go back, 3 first, 5 second, 1/3, 1/4. So what we are doing is we are multiplying 3 by 1, 5 by 2, 1 by 3, 1 by 4. You understand my point? So if we do this type of calculation, for example, Hawaii, 3 into 1. So 3 into 1 means 3 of them ranked it 1 first. 5 into 2 means 5 of them ranked them 2. 1 ranked them 3 and 1 ranked them 4. So we are multiplying and we are summing them up and we got a final score. So for Hawaii, we got 20. For Paris, we got 26. Greece, 26. And Hong Kong, 28. You understand the calculation? Okay. If you understand this, then can you tell me which one is ranked first? Which one is most preferred? Hong Kong? Hong Kong?
I think Hawaii.
You think Hawaii? You? Hong Kong? Most preferred, Greece. Why do you think Greece? Okay, anybody else with any other answer? Look how we actually calculated it. 3 of them ranked first, so we multiplied 3 by 1. 5 of them ranked second, so we multiplied 5 by 2. It means that higher ranking it gets, lower should be the cumulative value. Yes or no? For example, let's say Hawaii, all the 10 executives ranked Hawaii first. Then what would have been this result? I mean, how much score Hawaii would got? Total score? Total score would have been 10. If all the 10 executives would have ranked Hawaii 1, then the total score of Hawaii would have been 10. So actually, Hawaii is the most preferred one. Okay? So it got a score of 20, and since it's the lowest, because the lowest score means it's ranked high. Okay, so Hawaii is the most preferred one compared to other destinations. So this is another way of data transformation. That means we go for median split or index numbers or rank order for this data transformation. Now, apart from these points that we discussed earlier, for example, the tabulation, cross-tabulation, or contingency table, we also can present our data using different types of charts. Okay, for example, in the slide you can see it's a pie chart. So it's actually nothing different, or it's actually nothing new. Pie chart is a way of presenting your cross-tabulation. That means If you go for a cross tabulation, that will be, for example, a tabular form. But when you go for a pie chart, that's actually is a form of pie, or form of a circular diagram. So, for example, in this case, you have 3 pie charts. It's showing the proportion of consumers prefer different types of drinks. For example, beer, spirits, wine, and other. Okay? So you have 3 different times. One is 1992, another is 2005, and another is 2008. Now, if you would have gone for a cross tabulation, what you would have is a cross tabulation in the column. The cross tabulation would have, for example, 1992, 2005, and 2008, and in the rows it will have like beer, spirits, and wines. So the entire table will have some percentages. But instead of going this cross tabulation, if you go for these pie charts, you understand that your data presentation becomes more easier. Okay, more easier, and also it becomes easier for your readers to understand. For example, if you look at this pie chart in the extreme left, you can see that 47% of the respondents have a preference for beer, spirits have 21%, and 27% wine. Now, if you move from this one, I mean the extreme left pie chart, to the middle one, I think you can understand at a glance. At a glance, you can understand that when you move from these extreme left pie charts to the middle one, that beer has lost its popularity and wine's popularity has increased, don't we? We can immediately we can understand that beer is getting less popular and wine is getting more popular. And once again, if we move from the middle pie charts to the right one, immediately we understand that beer is regaining its popularity. Because you can see initially it was 47%, it declined to 36%, now it's 42%, so it's like regaining its popularity. And wine, that's popularity was increased, that again declined here. So this pie chart is a way of presenting data that might be more easier for our readers to understand. Now, some softwares that we use for descriptive analysis. First of all, the spreadsheet, that means the one that we use. We have seen how we can prepare descriptive statistics using Excel. We have seen it in the last class. We will also see these in today's workshop, that descriptive statistics and how to prepare cross tabulation, how to prepare histogram. And there is some statistical software, for example, SAS, SPSS, and Minitab. Is there anyone who are familiar with any of these? SAS, SPSS, Minitab? Anyone?
SPSS.
You used SPSS? So would you want to say a few sentences comparing SPSS and Excel, for example?
Oh, well, I mean, as the name implies, it's a package that's specifically built for statistics, so it has all of the high-level statistical tools built in, which admittedly now Excel does as well, but not to the level of SPSS.
Okay. Yes, SPSS is basically a statistical software. So most of the basic statistical techniques are built in SPSS. So it's very easy, it's a built-in interface. So you just get the data, you click a particular technique. For example, if you go for descriptive statistics, mean, median, mood, standard deviation, go for correlation, regression. And so all are built in, so if you just click, you will get the result, okay? SAS, the main difference between SAS and SPSS is, as I already have said, that in SPSS, the statistical techniques or statistical measures are built in, so you simply just click and get the result. But SAS is actually a program-based software. That means you need to write your programs. So that's make it's a little bit difficult, because those who do not have any programming language sometimes find it difficult using SAS. But one particular advantage of SAS over SPSS and Excel and Minitab as well, that SAS is particularly suitable for big data. That means if you have a huge data set, then you can go for SAS because SAS is particularly suitable. If you have a huge data, then SPSS and Excel are not good softwares because they cannot handle huge data. Okay. For example, I can give you my example. During my PhD, I worked on stock market data on 4 countries. One of them was India, and Indian stock market is one of the largest in the world. Okay, and there are about 7,000 stocks listed in Indian stock markets. 7,000 stocks listed. Do you have any idea how many stocks listed in Australian Stock Exchange? Any idea? About 2,000 companies listed in Australian Stock Exchange. So in India, there is 7,000 stock listed, and my time period was 20 years. Okay, 20 years. That's just one country I'm saying. I worked on 4 countries. So 7,000 stocks, 20 years, and I worked on daily data. Okay, so that's for one country. I have 3 other countries. So when I had this huge data and one particular program I was using, sometimes it happened that I command to execute a certain technique. I went to sleep at night, and when I wake up in the morning, I could find the result. So sometimes it took the whole night to run the program. Anyway, the point I'm trying to say that for big data, Excel, SPSS are not suitable. That particularly makes SAS popular, those who use big data. Minitab, it's my impression. I didn't use Minitab too much, but my impression is Minitab is less user-friendly compared to the other softwares. Anyway, so you can use any of them for this statistical analysis and for this descriptive analysis. So we are already familiar with the descriptive statistics that we get from Excel, because in the last workshop we found that how we get these descriptive analysis or descriptive statistics. Now this is an output. This is just to show you how it looks like when we generate it from SAS. Okay. So at the top of the slide you can see this is a SAS computer output of descriptive statistics. If you can remember in the last class when we have seen that the Excel output, we had 2 columns. Can you remember? We had 2 columns. In one column we had mean, standard deviation, range, and so on, and in the other column we had the numbers. But SAS is pretty much similar, but instead of just 2 columns, here we have 2 rows. Particularly, like if you take one variable, then you will have 2 rows. In one row, you will have variable, mean, standard deviation, mean, maximum, minimum, and in the other row, you will have the numbers. Okay, just like it's a column way. Excel presents the result in columns, and the SAS presents the results in rows. So this is how the result look like when we use SAS. Just I will complete our lecture session today, just say a few sentences about interpretation. You know that interpretation, when you are interpreting your result, that's particularly important because it has the managerial implication. Because you know that it doesn't matter that what your statistics says, what statistical analysis you use. So what matters is how you interpret your results, because on the basis of your interpretation as a researcher, managers will try to take the decisions. Okay, so you should be utmost careful that how you interpret your result, because that has the managerial implication, because that, like, your interpretation will basically be translated into managerial decision making. Okay, so in summary, we discuss today about how the different level of skill measurement can have impact on what descriptive statistics or what descriptive technique we use. We talked about different ways of presenting our data, for example, cross-tabulation, contingency table, quadrant analysis. Then we learned about basic data transformation techniques. So you understand that we are in week 6, so we are almost the halfway of our semester, isn't it? So from the next class and onwards, we will be basically learning the statistical technique, okay? Because as I told you that the descriptive statistics or descriptive analysis that we are discussing so far are not like a statistical test, okay? So from the next class, like week 7, week 8, 9, 10, 11, in these 5 weeks, we will be basically learning statistical techniques, okay? So and in these statistical techniques, we will be basically learning how we develop a hypothesis, and then using data, how we test the hypothesis. Okay. So so far we have the foundation, and we will try implementing those by data and by learning those statistical techniques. I understand that for some of you, using Excel and using this statistical technique are pretty much new. So I will suggest that if you, apart from this lecture or apart from the workshop, if you need any type of additional help, for example, using your Excel or using this type of statistics, there are some good readings, there are some good videos, okay? There is a different book on Excel. If you want any type of additional help you think, or if you think that you are struggling since you are a beginner with Excel and this is statistical technique, don't hesitate to contact me. I can suggest you, I can provide you some additional readings that will help you to like get easier your struggle. Okay, so that's the end of our lecture session, and after 5 minutes or so we will see the computer lab. Thank you. In the assessment, you will be using Excel in assessment too, but in exam, you are not expected to use Excel because your exam will be on this type of classroom conditions, so you won't have access to computer or Excel. So in your exam, basically, you will be given some results, and you will be interpreting results, or you will be like given a situation, so you will be asked to explain that what statistical technique should be used. So you will not be using, rather you will be interpreting or explaining.
So we get like outputs and stuff.
You are right. But shortly I will post.
Yeah, it will be good to look at. Like
Sure.
I'm used to that, like getting access to like all finals. So, but maybe that's not normal here. I don't know.
Okay, I will do that. No problem.
Yeah.
Probably this weekend.
Yeah, great.
Yes.
Could you tell me again about the project unlike the non-real?
Okay. What I have said is like what you need to do is, first of all, you need to have a budget, okay? And also time. The point I'm saying, it doesn't matter how much amount you come up with. You can come up with any amount. Okay, it doesn't matter like you need to know, oh, what's like actual expense. You need not to. You simply come up with any number, let's say $10,000. Okay? And any time period, let's say you say 3 months. Okay? Then what I expect that, okay, this is the total budget I need and this is the total time period I need. Then try to have these different stages of research. For example, questionnaire, data collection, okay, analysis, report preparation. Allocate this budget and this time to each of these stages. Okay, that's what we want. Okay, as I said that, just my objective is that you know that when you go for an actual research proposal, you know that you need a budget, you know that you need a time period, and you need to allocate both of them in these each stages of research. That means how much you need for questionnaire development, how much you need for data collection, how much you need for data analysis. So you just allocate them. And all these are arbitrary. You need not to know anything. It's just arbitrary. Okay?
Thank you very much.
Yeah.
Yeah, so that's all.
Just got a very quick question.
Yes.
With the assignment. I think I'm overthinking. Okay. The general global industry is moving online for banking, and we're subsequently having an increase in fraud.
Right.
Okay.
Right.
But does Visa have a problem? So I'm trying to think from this perspective. Should I be going to the company records and getting trends and going, oh yeah, no, we are picking?
Well,
Or does that assume in this that Visa has a problem, so therefore we need to go out to the general audience and tap how their experiences are? I'm just trying to figure in my mind.
It's not necessary that Visa has a problem, but the point is mostly is the customer perception.
Yes.
Like how customer perceive about the security system of Visa.
Which is influenced by what's happening out
You are right. So I'm simply asking you, oh, okay, you are a Visa card holder. Do you think that you have enough security provided by your bank? Or like I can ask you, okay, did you ever have a fraud? You said yes. Then like, how was it resolved? Okay,
Yes.
so all this is a customer perception about.
So it doesn't have to be with Visa really.
Not really.
No.
So it's simply like if I ask you that how satisfied you are with this device, it does not necessarily mean that this device has any problem. You are simply asking me that what is my perception about this. That's all. You should go for.
So some people stay away from computers just simply because they don't want to. Yeah. Okay. So there's a lot. Yeah.
I understand it's like a little bit of abstract, but you have the liberty to come up with the way you see the problem, the way you solve it.
Okay.
It's not necessary like I'm restricting you to think anything.
No.
It's you have liberty.
Yeah. Okay.
Hi, my name's Elliot. I emailed you the other day about that I was struggling to get to class.
Okay.
And,
Yeah.
I sent you that doctor's note.
Oh yes.
Yeah.
Yes.
So I'm getting an injection on Friday that should hopefully fix my problem.
Okay.
But if I have an adverse result from the anesthesia, I might have to put in an adverse circumstances.
It's all right.
I just thought I'd let you know in advance if that happens.
No problem. You just put it in, and it will come through to me, and I will approve.
Yeah, because I'll send you the note that I'll get with that on Friday as well.
That's all right.
Yeah.
No problem.
Yeah. Thank you. All right.
Yep. Let's walk and talk.
Yeah, I'm gonna go back there now.